My name is Jannick Demanet. I'm from the Department of Sociology at Ghent University. I'm a postdoc, so in sociology, and my research is about school effects. So in my research, I mainly use multi-level analysis. So that's why they asked me here today to give a lecture on multi-level analysis in educational research. And I'll focus on analyzing structural school influences on student outcomes. So we'll start with analyzing structural school effects and then look at how we can explain them by looking at more cultural measures, cultures of students and cultures of teachers in the same school. So this is the outline of the lecture. Today I will start with the theoretical and methodological need for multi-level analyses. Of course, there's a statistical need to do multi-level analysis, but in the social sciences there's also a theoretical need to do so. So I'll go briefly into these two kinds of rationales for doing multi-level analysis in the social sciences. Then I'll talk a bit about the main theoretical model underlying my work, so the structural school influences being mediated by cultures and processes, etc. Then third, I look at how you can incorporate the teacher side of the story in multi-level analyses, so incorporating teachers' effects. I'll go into the Pygmalion study and the Pygmalion effect, etc. in that part. And then I will end with a basic part about extending the basic multi-level model. And I'll look briefly at how you can use it for cross-national research, for example. That's the idea of the lecture today. So, in the social sciences, of course, we know that we actually live in a multi-level world. We live in a world, of course, but especially in sociology, we know that we are impacted on by the contexts in which we reside. So the contexts, they have some characteristics which influence us when we reside in them. So especially in sociology, we have a lot of attention for the context. And that idea dates back on the ideas of Emil Durkheim, which was, of course, one of the founding fathers of sociology. He was one of the first to draw attention to what it can mean for you, for your outcomes of residing in a particular context. So he's one of the main founders of the ideas of structuralism in sociology. And his main point was that there are social facts. So those are structural effects arising, structural characteristics of a context which can have effects on people residing in those contexts. Now, these social facts, according to Emil Durkheim, are external, so they are not characteristics of individuals of the context. It's really a contextual feature. They are coercive, which means that they have an impact on everyone residing in those contexts. So you cannot choose as an individual of having the effect or not. So it's actually obliged, it's coercive when you're in that context that there's an effect. It's collective, it's for everybody residing in the context, and you can measure it. They are things. So of course he goes back on the ideas of physics. Those were also concepts, things that you can measure with empirical data, and he says that in sociology, those social facts, they can be measurable through science, through statistics, for example. One of the things that he's shown, of course, is that, that some features of a context, of a society can exert an influence on suicide rates, for example. So integration and the regulation in society, if it's too high or if it's too low, can have an effect on suicide rates. Okay, so you see that that's one of the first ideas that features of a context, so integration, regulation, has an effect on people residing in those contexts. So you see that actually that's a multi-level idea already. The features of the context are on the second level, and features of the individuals, of course, are on the lowest level. But statistics were not far enough at that date, of course, to grasp all that empirically in the right manner. Then we fast forward to the 80s, where we have Peter Blau, one of the other exponents of structuralism in sociology, and he is the founding man behind macrostructural theory. The main idea of that theory is that differentiation in a context leads to integration between people of different groups. For example, ethnic heterogeneity, if there are different ethnicities in a context, then people will have contact with people from other ethnic groups, from your outgroup. If everybody's the same, then that's more difficult. So it's not possible to have, or less possible, of course, to have contact with people from your outgroup. And the idea is that everybody prefers contact with others from your in-group, but everybody prefers out-group context above no contacts at all. So if this guy, for example, only wants in-group context, then he will be alone in this context because there's nobody else from his in-group. So he has to, if he wants to have contacts with other people, he has to make connections with the others in the context, and so he will have out-group connections. That's the idea of macrostructural theory. So differentiation leads to integration between people from different groups. Differentiation, of course, is contextual characteristics. It's the ethnic diversity of the context is a characteristic at the higher level. Integration, for example, cross-ethnic friendships, etc., that's an individual characteristic. You can measure for this guy, for example, how many friendships he has. See? So here you see again that a concept at a higher level impacts a concept at a lower level. So theoretically, we need multi-level analysis, multi-level methodology to grasp what these guys are talking about. In educational research, we see the same. So students, of course, are residing within schools, and the school is like, you could say, a structural cage. I think this is very well shown by this figure here. The school is a structural cage limiting contact with people from other schools, and of course increasing contact between students belonging to the same school. So students interact within a context, with the other students, of course, present in the context. But they also interact with the school context itself. The school context, of course, is a second level thing. It's something at the higher level, at the aggregate level. It's a contextual feature. And students in those contexts are at the lowest level. So they are individuals at a lower level. We also know that schools have characteristics of its own. For example, like I've said with Peter below, the ethnic diversity of a school. You can measure that by looking at how many immigrants are there in a school, what is the percentage. Or you can look at the ethnic group, what is the percentage of Turkish people, American people, Russian people, etc. in the school, and then you can make an index of heterogeneity. That's a characteristic of the school, or the SES composition of the school, the percentage of students coming from a labor background, for example, from a blue-collar background. You see, those are characteristics of the school. And it is possible that those characteristics at the school level have an effect on the people residing in those schools. If you look at the ideas of Emil Durkheim, these actually are social facts, and these have coercive, external, etc. effects on the people residing in those contexts. Okay? So possible research questions in a school context may be, what is the impact of the school size, a contextual feature, on the quality of friendship relations, which are individual features, which is an individual feature. What is the impact of the ethnic composition on interethnic prejudice, for example? What is the impact of school policy decisions on students' well-being? So we make the assumption here, or we will investigate here, whether students belonging to the same school undergo the same effects of those structural features at the school level. That's the idea. If we go into the statistics then, if we start there, then we can see that educational data is nested. It has a nested structure. Students belong to a school. You see? So all these students belong to the same school. All these students belong to this school. All these students belong to this school. So students are nested within schools, which means that every lower level unit belongs to only one higher level unit. And of course you can go further. A school belongs to a community belongs to a nation belongs to some supranational things, etc. So there are a lot of levels in educational research. Now what we see here is that students in the same school, they tend to score alike, they tend to think alike, they tend to behave alike. Why? Of course, because they are subject to the same external constraints, because they are subject to the same structural effects of the school. So eventually, over time, they tend to become alike, okay? So some values on individual measures, they cluster together in every school. And you can say that about everything. About students' well-being, about their achievement, for example, about their attitudes, about their friendships, etc. Okay? So you could say that all these values here at the lower level, they are actually dependent upon one another, because everybody who is clustered in the same higher level unit tends to score alike. Okay? So these two students will be much more alike than this student and this student. All right? And we have a name for that. It's called autocorrelation. And the problem is that, the absence of autocorrelation is one of the basic assumptions for ordinary regression analysis. Values should be independent for one another before you can let loose your ordinary regression analysis on it. So the problem is, of course, that if you have nested data in educational research, that you can't just look at it, analyze it with simple ordinary regression analysis, because there is autocorrelation, because these students score alike, and these students score alike, and these students score alike. Now, what is the problem with autocorrelation, of course? Well, that when you try to do significance testing in your ordinary regression analyses, that your standard error of the regression coefficient, so when you do this kind of analysis, of course, you have your coefficient, your regression coefficient, and it has a standard error. That standard error is underestimated when you have autocorrelation. It becomes too small. So if this is the distribution of your regression coefficient, then if you have autocorrelation, then this will become smaller, because your, again, standard error, which of course is the standard deviation of this normal curve, becomes smaller. Too small, actually smaller than it is in reality, because that's the problem. You estimate it too small, it becomes too small. Now, as our t coefficient, which is of course the basis for a significance testing, is our regression coefficient divided by the standard error, and if this becomes too small, then our t becomes too large. Again, it's actually larger than it is in reality. So you make a mistake, you make an error. You estimate it too large than it actually is, okay? Which means that your p-value, which is the chance that you have a coefficient which is larger or equal to your t, as your t is larger, then your p becomes smaller again, okay? So your estimation of your chance that the null hypothesis, is correct is actually underestimated. So you would be more likely to reject a correct null hypothesis. All right? So in common terms, your conclusions are invalid. If you don't understand the statistical part of the thing, the idea is just that your significance testing is invalid. In other words, you will get more significant effects that actually are not significant. So you will draw wrong conclusions, all right? Is that clear? Yes. All right. And of course, that's because we have this situation. Okay. So you can try to do something about that. We have two wrong solutions to deal with this, which has been, these solutions have been done a lot in social sciences before we had the computer models for multi-level models, okay? So this is what they did. Wrong solution 1, just disaggregate everything, which means that you will put some school level variables at the individual level, okay? So this is what disaggregating means, of course. This is how your SPSS looks then. So you have two schools here. These are the school IDs. These are the students' gender. Let's say 0 are girls, 1 are boys. And this is the school size, which is of course a school level characteristic. N is of course the same for every student belonging to the same school. Okay, So you can do that. You can just put that in SPSS and say, SPSS, give me an ordinary regression analysis of school size and gender on belonging, for example, another characteristic, an individual characteristic. Of course, here we have autocorrelation. Not only because these students in the same school score exactly alike on the school level features, but also because they scored alike, they tend to score alike on individual features. Let's say, for example, that a school adopts a single-sex policy, only girls are allowed. Then, of course, everyone, let's say in school 3, is a girl. See? So this is an individual level feature, which is not independent from one another because a school level policy choice has made everybody the same. This is, of course, very extreme, but if you have a tracked system, for example, and there's a school who only does car mechanics, for example, then we will have more boys. There will be some girls, of course, but more boys, you see? So every school level policy decision, every compositional characteristic, for example, at the school level, will ensure that some individual level measures, even something that is inalterable or as gender, tends to become the same, tends to score alike. Okay, and this is, of course, what autocorrelation is. So here, higher level values are exploded, they are expanded. They don't figure just once for each school, but they tend to be replicated over all the students in the same school. And it's easier, as I told you before, to find significance because your standard error becomes smaller, which means that your t gets larger and your p-value will become smaller and smaller. So it's much easier to find significance here. But wrong significance, your conclusions will be invalid. Of course, as researchers, we aim for that significance, but if it's wrong, yeah, of course, then you will draw the wrong conclusions about reality. Okay, so this is a very big problem in educational research. More theoretic, on a more theoretical note, you actually make an atomistic fallacy here, which means that you make assumptions about higher level explanations. Here, school size has an effect on the basis of lower level data, individual level analyses. So this is what we call an atomistic fallacy. And that's on a more philosophical note, maybe, that's wrong. You can't make predictions or explanations at a higher level by just using lower level data. So this is wrong. Second wrong solution that has been done, aggregate everything. So if you, of course, only have analyses for doing single level analysis, you can bring everything down to the lower level, or you can just lift everything up to the higher level. Then this is how the same data looks when you aggregate everything. So here the units are not like here the individuals, the students, but they're the school here. So we have the school ID, of course, the school size. It's okay now because it's only figured once for each school. And we have the gender composition, you could say here, of the same data. Okay, so now you're assessing the individual level variables, gender, at the higher level. Of course, you lose a lot of information here because you have no information about every student anymore, just about every school. So this is really condensed. You only have 2 units here, your n becomes much smaller, of course. Here you had 15 units. You lose a lot of information. You also lose a lot of level 1 variance, of course, because the entire distribution within one school is just collapsed in one measure. So you lose all that variance. But variance is very important for statistics. This is what we want to explain, variance. So that's a big problem. And that means that effects are blown up. Effect sizes become larger here, because you lose all that variance. Again, on a more philosophical note, you make an ecological fallacy here, which is, of course, the inverse of the atomistic fallacy. You're making assumptions about lower level explanations. For example, if you look here at the effect of gender, then you don't have the effect of an individual's gender here, you have the effect of a gender composition. But you are making statements about gender effects. So based on higher level data, you're saying something about lower level explanations. It's like saying that when people go to school where there are more immigrants, they achieve less, so that's a higher level effect. It's like saying, if that occurs, that every immigrant or that immigrants have a lower achievement, you see? So it's not because the ethnic composition has an effect, that also occurs for the individual effect of being an immigrant, okay? So you can't just make explanations, assumptions about individual level effects based on higher level data, okay? So this is the second wrong solution. The right solution, of course, is multi-level models. Because what multi-level models do, they do not treat it as one sample, like here, sample of schools, like here, sample of students. No, they treat it as two separate samples. As a sample of schools, and within those schools, a sample of students. So significance testing is not done with the N of either the schools or either the students, but at the higher level, the N of the schools is used. At the lower level, the N of the students is used. So this is one of the first basic things that you need to know about multi-level analyses. If you, for example, only have 15 schools, but you have, let's say, 20,000 students, then the significance testing at the school level only uses the 15 schools. And we know that if the N, of course, is smaller, then it's much harder to gain significant results, okay? And at the student level, 20,000 students are used. So it's much easier to find significant effects at the individual level than at the higher level. This is important to know. Even if you, again, have a sample of 20,000 students, but they only come from 2 schools, for example, let's make it very extreme, then you will not find any significant effects at the higher level, because you only have 2 schools. All right? So, if you want to build multi-level analysis and you have money for an investigation, then you can't only aim for a lot of students, even if you will have a low number of schools. You will have to put your money in gaining access to a lot of schools, and in those schools a lot of students. Okay, so you have to look at both those levels. And of course you have to make sure that the variables are entered at the adequate level. If you have school features like gender composition or school size or so, etc., you have to put it in at the second level. Sorry. If you have individual level things, then they should be entered at the lower level. This looks very simple and and straightforward, of course, but a lot of people make mistakes there. Make sure that you have theoretical rationale at each level to put variables in at the correct level. So that's an important point. Okay, and the main idea of multi-level models now is that you have models with a fixed part and a random part. And the random part, that is where multi-level models differ from ordinary regression analysis. So there's more randomness in multi-level models than there is in ordinary regression analyses. Okay, randomness, things can differ across contexts, across individuals, etc. Okay, we'll see how we do that. So this is, of course, what we have in ordinary regression analyses. We have a fixed part of the model. This is the fixed part, where we, of course, have our outcome, the intercept, the regression coefficient, the variable. This is the fixed part. The intercept is the same for every respondent, in every context, in every school, and the regression coefficient also is the same for every respondent in every school, etc. There is a random part, which is the error term. This is what ensures that there is still variability across respondents. Okay? Those are the residuals of our model. It's what ensures that individuals deviate from our general regression line. All right? In multi-level analyses, intercepts can vary across schools, for example, and slopes can vary. Regression coefficients can vary across schools, for example. Okay? So this is the fundamental difference between multi-level analyses and ordinary regression analyses. Okay? In ordinary regression analysis, I say it again, intercept is the same in every context, for every respondent, and the slope also is the same for every coefficient, for every context, for every respondent. In multi-level analysis, these are allowed to vary. Okay. What is the first step always in a multi-level model? First, you have to check whether a multi-level model is necessary. This is what we call a null model. It's just a model where there are no independent variables entered in the model and you only have your dependent variable. This is how that looks. So this is the first time now that we see the formulas of multi-level models. We'll see how this looks. So you see that you have a level 1 model, which is the model for the students at the student level. And you have a level 2 model, which is the model at the school level. Okay. So how does it look at the individual level? Just the same as an ordinary regression analysis. Just the same. So your dependent here is belonging. I picked belonging because as sociologists we're all interested in that, of course. So belonging is our dependent here. This is the intercept. And this is the error term. So no variables, of course, are entered. So this x here is erased. And you have the intercept and the error term. The notation is a little bit different, but it's actually the same. This is, you could say B0, so the intercept, and the R here is not correlation or something, it's the error term. Okay, so this is a notation by HLM. Now what is different is that the intercept reappears at the higher level. So this intercept here becomes your dependent at the higher level, at the school level. It's explained by a coefficient. It's actually also an intercept, but it's a gamma, not a beta coefficient, because beta coefficients are for the lower level. Gamma coefficients are for higher level. They're actually the coefficients of school effects, you can say. But there are no school features entered at this point, so you only have an intercept again. And this is what makes it a multi-level model. The U, they call it a variance component, and it's actually just the same as an error, as a residual. It's actually just the same as this R or as this E here, but it's the one at the school level. See? The J that appears here in the subscript, so this is the intercept dependent upon J, means that it can differ across context schools with the subscript J. So school 1 is J is 1, school 2, J is 2, etc. Okay? So the J here means that this intercept can vary across schools, so it's a random. It can be random, okay? It differs across contexts. This does not differ across contexts because there's no J in there, but this is an error term across school contexts. This is just a random part. This is the random part of the model at the school level, making sure that there is variation between contexts in this intercept. Okay? And as I said here, the difference between a multi-level model and an ordinary regression model is that this intercept can vary across contexts. And this is just what this formula does. This part makes sure that this intercept can vary across contexts. Okay? This is how your null model looks. All right. So then you assess it. You let it run. And this is what you get. Of course, fit it in a nice table, etc. This is what you get. You have an intercept, which is this one. Okay? And this is the variance of that intercept within schools and between schools. This is the error term here at the individual level. Within schools, variance at individual level. This is variance between schools, variance at the school level. This is our U. This one. And this one says that it's significant. Okay? You can see that in outputs whether this variance component is significant. There's a significance test saying whether it differs from 0 or not. Here it differs from 0. This means that this u is not 0, which means that there is a random part that is significant, which means that this intercept differs across contexts, and that you need multi-level analysis to assess this outcome. All right? Okay. If this would not be significant, then this is 0, so you can just erase it in your mind, which means that it's the same across all contexts because there is no variance anymore. Your intercept is the same, so there's no need for multi-level analysis. Okay? So this is the first step, always the first step. Always start with a null model to see whether it's necessary to do a multi-level analysis. What you can do is you can calculate the proportion of the variance at the school level. Okay? So here that's for my belonging characteristic, that's 7.7%. How do I do that? I haven't put it on the slide, but how do you do it? The between schools variance is 0.25, and you divide it by the sum of the between school variance and the within school variance. It's actually like a kind of ANOVA, okay? Where you partition the entire variance between groups and within groups, but the entire variance is the variance between and within groups summed, okay? So if you divide this by the total of the variances, which is the sum of the two parts, then you get the percentage of the variance at the school level. Okay? So this can be significant, but only 1%. This means that only 1% of the variance is due to school effects. Okay? If this would be 50%, for example, that would be incredibly large for a multi-level analysis, because it means that 50% of your outcome is determined by school features. All right? You could say this is not that large, but this means that 7% of the entire variance in belonging is due to differences between schools. So I think that's quite large, all right? But this will always be smaller than 10%, I think. If you have it more than 10%, then you have a very, very strong case for multi-level analysis. All right, so in very important first part. You will never do a multi-level analysis if this is not significant because you don't have differences between contexts. All right. And then you have two possibilities. And that's just where you want to invoke your randomness in the models. You can put your intercept at random, and you can also put your slopes at random. Of course, to have a slope, you need to have at least one independent variable. And in the null model, we don't have that, okay? We'll start with this one. This is a random intercept fixed slope model. Means that the intercept differs between contexts, but the individual independent variable, its effect, is the same across all contexts. You see that here in the figure. So this is the effect of SES on achievement. We all know that if you're from a higher social class, that you will do better at school. And here the intercepts are allowed to vary. All these lines are lines in different schools, all right? At different second level units. And you see that the effect of SES on achievement is exactly the same in every school because the slope is the same, all right? But in the first school, they already had a higher achievement to start with, you can say. All right? So that's why their line is higher, of course. So the effect of SES on achievement is the same in every school here, but there are between school differences in the intercept. All right? And then you can try to explain this by adding school level features. Saying, for example, okay, this is the school with a higher SES composition, all right? So the SES composition itself already has a high effect, has a positive effect on achievement. This is a school with a low SES composition, where the effect of individual SES is the same within the school, but the SES composition of the school itself is so low that the overall achievement in that school is already lower. All right? This is a random slope model. A random intercept model. All right. This is a full random model, you could say, where the intercept and the slopes are allowed to vary. You see? So again, for schools, there's differences in intercept. So for example, the SES composition has an effect again. But the SES composition also determines the effect of individual SES. For example, here in the school with a low SES composition, having a higher individual SES doesn't make a large difference for your own achievement. But in the school with a high SES composition, having an individual higher SES than your fellow students in the same school, right, has a larger effect. All right? And they also call this a cross-level interaction effect. Because actually there's an interaction between the two variables going on. An interaction between SES composition at the higher level and individual SES at the lower level. Okay? So here you can introduce school-level features to explain your different intercepts. Here you can also introduce them to explain your different intercepts, but you can also introduce them to explain your different effects of individual level variables, your different slopes. And this is how that looks in HLM, in formulas. This is a random intercept fixed slope model. So here you see that belonging, I just used the same example as for the null model. Belonging is explained by the intercept by a slope times your variable, which is here whether students' parents are unemployed or not, for example, and your random error term. Fixed part, random part. The intercept is allowed to vary across schools. You see that the U here is, you can say, put on in your HLM. So it's allowed to vary. It has to be estimated. But the other U, maybe you can see it as well, is gray, which means that you have put it off, you have disabled your U, and you have fixed the effect of the slope. Okay? Again, the slope is the same in every school because there is no random part that makes it differ across schools. So there's a J here, but actually it depends upon the same coefficient in every school. There's a J in the intercept, and that is allowed to vary because this U is enabled. All right? Do you understand this? So the intercept is allowed to vary. And so what you can do then is you can introduce SES composition, for example, the percentage of unemployed students or students with unemployed parents. You can introduce that here to explain your differences in intercept. All right? So what I said is level 2 variables inserted at the level 2 model. Level 1 variables have to be put here in the level 1 model. All right. This is a full random model, random intercept and random slopes model. And you can see that here, the two U's are enabled. So both the intercept and the slope of your individual level characteristics is allowed to vary. All right? And then you can put, again, SES composition to explain the intercepts, but you can also put it here to explain your slopes. And when you put it here, you have a cross-level interaction effect. All right? Because the slope, and actually that's what an interaction effect is, the slope of one variable depends on the value of another variable. The slope of one variable can depend on another variable, but the variable here will be a school level variable. The variable here is an individual level variable. So that's why they call it a cross-level interaction effect. All right? Oh yeah, I did it here, sorry. See, here the SES composition is introduced to explain these effects. All right, so this is the statistics for today. All right? Let's start with the general theoretical model underlying multi-level analysis then. The general theoretical model is made up of three components. We have input variables, structural features at the individual level, but also at the school level. So, can be the gender composition, the ethnic composition of the school, or the gender of the students, whether they were immigrants or not, etc. Structural features. These can affect student outcomes, achievement, belonging, for example, everything that you're interested in. Most previous models, and I'll go into that later, only looks at this. They just put some school level characteristic or an individual level characteristic in the model, and they see, does it have an effect on my outcome? And we're there. For example, girls do better at school than boys. Let's publish it and start at a new study. This was what previous studies did. We call them input-output studies. You put something in the model, something comes out, and you publish it. All right? But you do not get any insight into what is happening in those models. You don't know why girls do better than boys, or boys do better than girls, in maths, for example. All right? This is why you should incorporate processes, because things at the input side affect things at the output side by putting some dynamic things in motion, of course, by affecting something that happens in a school context, processes, all right? These can be more dynamic things, like how people think, how they behave, the relationships that they have with each other or with their teachers, for example. So this is about attitudes, it's about behaviors, and it's about relationships. And they can be at the individual level, how students think, behave, etc. They can also be at the school level. So you also have school level processes. It's more the dynamic side of a school context. All right. Of course, you need different kinds of data for this. First, you need to have individual data, because this is the thing about multi-level analysis. You can only explain variables at the lowest level. Okay? So what we have here, for example, what we have here in our HLM, our outcome can only be at the lowest level. There's no possibility of explaining school level features by individual level features. Okay, so that's something that I didn't stress before, but it's important to know. All right. So of course you need individual level data. These are student properties. If you doubt whether a variable that you have is situated at the lowest level or at the highest level, you can just look at where the differences are. If variables' values can differ between students within the same school, then it's an individual level characteristic. If it cannot, then it's a school level characteristic. Okay? Here, differences between students. So the gender composition of a school cannot differ across students. I'm in a school with 50% boys. Then the other student, I'm also in a school with 50% boys. You see? I'm a boy, that's a girl. That's a difference. All right? Examples, some socio-demographics, gender, ethnicity, your SES, your home language, etc. These are structural things, but they can also look at processes, like I've explained. So they can be attitudes, they can be behavior, etc. Those are individual level things. Achievement, for example, things that we want to explain. Ability on a PISA test, for example, right? School level things are things that can differ between schools, but not between students. And maybe on a more theoretical note here, we can distinguish between several different features of a school. There's a lot of debate about these things. Should be quite honest about that. Okay? Some researchers call everything school climate. Some call everything school culture, etc. So there's a lot of debate on that. I follow the studies that appear in my further reading section at the end of this presentation. So this is what I will bring forward, but there's discussion about this. So what we do is we distinguish between structural school features, school size, which tracks there are in a school, for example. Those are really structural things, all right? And school climate. School climate actually is a sort of an umbrella concept which has 4 subdimensions. Within the school climate, we have the ecological environment, and those are really the building makeup of a school. How many rooms do they have? How are they organized? Is there a playground? Are there trees on the playground, for example? So really the ecological environment of where you are. Here in the room, we also have the ecological environment, all right? So it, of course, structures how you behave. Because here, I don't have a blackboard, for example, on which I can write freely. So, of course, that has an effect on how I am presenting at the moment. All right, so the ecological environment is quite important. But there's not a lot of research on that. All right, but it's one of the components of the school climate. Second thing is the social milieu. And what is that? That is the composition. So you can say the social makeup of a population. Percentage of girls, percentage of immigrants, how many retained students are there in the school, how many speak a foreign language. You can just go on. You have the social milieu of the student population. You also have the same of the teacher population. How many women are teaching? How old are they? How many experience do they have, etc. Okay, so it falls into these 2 things. Then you have the social system, and that's really about the relationships between students, between teachers, and between students and teachers. Right? So it's everything to do with social contact at the school level. All right. And then the last thing is the school culture. And the school culture is how students and teachers think. What are their attitudes? But on the school level. So it's important to know that this only exists if students tend to think alike, when students in the same school think the same or roughly the same about things, about their future, about their school career, about politics, for example, then you have a school culture of politics, of their future, etc., aspirations, etc., okay? The different dimensions within the school culture. You also have a teacher culture, but only when, again, teachers think alike. If everybody thinks in a different way at school, then you don't have a culture. So we go back on the more anthropological definitions of a culture, which are just shared attitudes. People thinking the same. If they think the same, you have a culture. All right? That's the idea here. And that's one of the sub-dimensions of school climate. Other researchers would say that this is the school culture and that this is the climate. All right? So there's a really large conceptual discussion on these kind of things, again. But I think this is workable. This is something that you can use in empirical research. All right, so let's proceed. We're now in the second part. And I'll just go further from what I just said. So these are the theoretical parts of the school climate. And now I'll fit these into my general scheme of input, processes, and output. Because you can't just see all of them as the input side or at the processes side. Again, they can be outputs because they're at the school level, all right? So they should be at the school level. First, we have structural school characteristics, and these are at the input side. And that's about the form of contextual arrangements. So not about the meaning, not about the subjective interpretation of where people reside, but really about how it's formed, how it's made up, all right? So these are structural school things. What I see here are, of course, everything that I've placed under the structural things, like tracks, track organization, school size, etc. School sector is also one of those things. It's a public or a private school, right? The composition, social milieu part of it is also a structural thing. Okay, so the gender composition, the SES composition, the ethnic composition, etc. And the ecological environment is also about form, so it's also about the structural things. As I've said, it's about buildings, classroom makeup, at playgrounds. I think there's a lot of excellent research that could be done in these things, because that would be quite innovative. It's really seldom studied, but I can imagine that there's really terrific work that can be done about how playgrounds are made up, etc. How the corridors to the classroom are made up, etc. So really interesting things that can be done here, I think, but are not yet done. At the school level, we also have things under the processes, and here I place the social system, the relationships, because that's really a dynamic part about school life is filled in. Do you have a lot of good relationships with your peers? Do you have a lot of good relationships with your teachers? Are there a lot of good relationships between the teachers in your schools? And you can divide that between the quantity of relationships. For example, how many friends do you have? Or by how many students are you bullied, for example? That's also, of course, a quite negative relationship, also part of the social system. And the quality of your relationship. You can have 1,000 Facebook friends. I don't know if it's possible on Facebook, but is it possible? Okay, I'm not on Facebook, so sorry. That you can have 1,000 friendships, but you don't meet one at all. Okay, so then you have a very large quantity of friendships, but very poor quality. At school you can also have that. If you're the popular kid, for example, you can say, oh, I have 50 friends here at school, but they always play without me. Okay, so you have a high quantity of friendship relationships, but quality is quite poor. You can also have only 2 friends, but you see them all the time. You're always together in class. You see each other every Wednesday afternoon when there's no school. You sleep together in the weekends, for example. So that's low quantity, but high quality. Okay, so this is what can be said. But again, it's at the school level. So you can say the percentage of cross-ethnic friendships, for example, the number of cross-ethnic friendships at the school level. I can also look at the cohesion at the school level. How well is this group knit together? Between students and teachers, between teachers again, okay? And then of course we have the school culture. I have already talked about that. Attitudes shared by actors belonging to the same school. You can look at that in the student side or at the teacher side. Now I go into, again, a statistical part. How do we measure school culture? Because of course it's on a theoretical, anthropological, philosophical note, very easy to say, oh, these are attitudes shared by the students of the same school, and they have effects, of course. What we want to do with statistics is to assess whether they have effects. So we have to operationalize this as a kind of a variable. So what we do is we aggregate, sometimes it's allowed, okay? We aggregate attitudes to the school level. What do? We have a scale for every student. How much does he feel or she feel that she belongs to the school context, right? So that's an attitude individual score, and then we just take the mean in every school, all right? Then we have aggregated it. But what we haven't done then is looked if it's really a culture, if it's actually shared. It's very possible if everybody thinks in a different direction, just to take the mean and say, I have a culture. Okay, so that's not enough, of course. You really have to look statistically whether these attitudes are shared. How we can do that? With a simple analysis of variance, with an ANOVA. All right? What is the idea of an ANOVA? Well, you have, of course, different groups, a factor variable, categorical variable that makes different groups in your data. Here I have 3 groups. And it looks at the ratio of within group differences and between group differences. You can see that here quite good. Here you have differences between groups. In this group here, they tend to think a little bit more positive than here. They score a little bit higher, if you want it in a more statistical sense, than here. But there's a lot of variability within the group. Here, just the same thing. You see that the means are the same between the two pictures here, but the variability is much smaller within each group. So an ANOVA will look at between school differences divided by within school differences, and then look at if it's significantly different from 1. All right, so that's the idea of an ANOVA. Now, we use it here in a slightly different sense, but actually it comes to the same conclusion. So it's actually just a simple ANOVA. What we do here is, and we call that an index of mean rater reliability. It's also in the texts on the further reading section. I will go. We'll say that then. The idea is that you take the between mean sum of squares. You subtract from it the within mean sum of squares, and you divide it again by the between mean sum of squares. So you just take the difference between between and within. You divide it by the between, and that index should be larger than 0.60, than 0.60. All right? If it's larger than 0.60, then that means, just what I said here, that the between school differences in your attitudes are larger than your within school differences in your attitudes, meaning indeed that attitudes are shared within each school. Okay, so that's something that you have to do in SPSS. Do an ANOVA, you get your means, your mean sum of squares between, subtracted with within, and then you divide it again by the between. And then if it's shared, then we can take the mean for each school. Now actually you can do two things. You can take the mean for each school if you're interested in the general tendency, the general culture. What is the general the idea of this attitude within the school? It's also interesting to calculate the standard deviation in each school, because then you have a measure looking at heterogeneity of attitudes. So whether the culture really is strongly related, if they are strongly shared, or there's more variability. All right? So, and there's research originating now, it's also quite new, not to only include this mean, but also the standard deviation in the culture. All right? And looking at, for example, if there's a high heterogeneity between teachers on a certain attitude, so if there's a lot of variability, if that has an effect on some student outcomes. Not only general tendency, but the variability. And then, of course, that can differ between schools. There can be a high variability here, very low here, again, very high here, etc. And then you can look at the effect of that. So that's quite interesting stuff, I think. When we go back to the theoretical model then, input, process, output, previous traditional school effect studies, they mainly use large-scale data sets. It doesn't have to be cross-national. Also in specific countries like America or in the Netherlands or in Flanders, there's a large tradition of these school effect studies. So what they do is they have large data sets and they just model after model after model, put every structural school characteristic that they find in there, and then they see what the effect is on some student outcomes. And the main idea, the main question driving these studies is whether the school a child attends makes a difference. So they are satisfied if they can say, yes, the school makes a difference. What they cannot say is why the school makes a difference. All right? So these mostly remain input-output studies. They are atheoretical. There's no theory. They just say, we want to investigate whether there are between school differences, whether the gender composition, ethnic composition, SES composition, everything they want to put in there has an effect. They do some analyses, multi-level analysis, and then they find effects. And they say, oh yeah, it makes a difference. But there's no theory guiding this research. And that's one of the main critiques, of course, especially made by sociologists, who are very good in theory, by the way, made on these educational scientist studies. All right? Because statistics, of course, can only prove that much. We all know that there are type 1 errors, type 2 errors possible. And especially when you only have a limited number of schools, then it becomes tricky just to look at your data. So you really need to have theoretical rationale for assessing structural school effects. That is important because there are some studies that show that compositional effects, like gender composition, ethnic composition, etc., they may sometimes be statistical artifacts, just artifacts of your data, because you aggregate individual level data to the school level, for example, to calculate your gender composition, and then you look again at effects on an individual level outcome, and it can be that you find effects just because it's an artifact of how you do your statistics. If you have theoretical models, then your case is much stronger for saying that they are not statistical artifacts. All right? So that's an important point, that if you want to do school effect studies, you really need theory. That's one of the main points that I want to make today. All right? So that's important. If you only do this, so input school level, student level, on a student outcome, then you first can have statistical artifacts, but also you can't explain why you find these relationships. So they remain black boxes. Where you have the input side, structural features, everything that I named under structural features of the schools. So school size, tracks, compositions, ecological environment, everything that you can name there, of course. It has an effect on outcomes, you can look at that. Sociodemographics also have an effect on outcomes, but why? So that's why we really place a lot of emphasis on these processes. Processes are attitudes, so they are culture at the school level, but also the social system. You have this on the school level, you also have this on the individual level. So if you look at everything together, then you see that the structural features can have an effect on the way people think in those schools, so the culture at the school level has an effect on an outcome. It can also determine the social system at the school. And that's where we need, for example, Peter Blau. You see, structural features, the heterogeneity, the differentiation of the school has an effect on between group interaction. You see, so that's a very interesting theory to suppose this or this, here going to the individual level, to the relationships that you have. You see. So it can be about attitudes at the school level, attitudes at the lower level, at the student level, or about the system at the higher level and the relationships at the lower level. And of course, the culture of a school also determines how individual students think, because as sociologists we know that there is socialization. And if you enter a certain culture, then you will be socialized into that culture. You will tend to think alike with the group that you are joining. Yeah? See the theory? So the culture affects your attitudes, but of course the general social system in the school also affects your relationships. And maybe the culture affects your relationships, because if everybody is quite admissive of inter-ethnic friendships, then you will have a larger chance of having inter-ethnic friendships. If the school thinks that it's quite okay to bully your fellow peers, then you will be more likely to bully your fellow peers, all right? And so we have these arrows as well. It is possible to put everything here in one multi-level model, but this is not the idea of this conceptual model, all right? The idea is that you will zoom in on several of these things, of these relationships, and you will just look at how everything works. I've brought an example to show how I did this in my own work. I will look at the effect of gender composition on school misconduct. Maybe I should say that my PhD was on school misconduct, so I'm interested in why students misbehave at school, and especially why the schools that they attend makes a difference in that deviance, all right, in that school misconduct. So multi-level analysis on school misconduct was or is my main part of research. So in this particular study, I was interested in the gender composition. Actually, very simple question. We know that boys misbehave much more than girls. If there are more girls at their school, are they, how do you say that? More obedient, all right? Or in another sense, if there are more boys in the girls' school, do they become deviant as well? So do they affect each other? That was the idea of this study. The theory, important for these kind of studies, is as follows. We know that there is a laddish culture. So that dates back on the idea of, on the research of Paul Willis. We know that there is a laddish culture, which means that for a boy, it's better to misbehave than to study. Because studying is not fitted for a boy. It's actually part of a feminine role set, of a feminine identity. Education, being quiet, being obedient, nodding if someone is talking, that's very fitting for a feminine role set. For a boy, it's better to disrupt the lessons. You gain popularity that way. You are a true boy if you don't pay attention in class. All right? That's the idea. That is the laddish culture. And that's one of the main explanations for boys' underachievement. I've already said it, that boys underachieve in nearly every educational system. Since the democratization of our education, we see that the girls, they have not only met the boys, but they have surpassed their achievement. They are more present in universities, etc. So they just do better. All right? Why? Because, as I said, study attitudes, good study attitudes are not fitted for a boy. They are actually more fitted for a girl. So there's a pressure, you could say that this is a culture, so they get socialized into that culture. There's a pressure for boys to show that they are actually not paying attention, even if they are actually paying attention, right? So even if you're studying at home, the next day you come in school and your friends ask you, have you studied yesterday? No, I've played my video games. You see? That's the idea. So there's a pressure for peer group integration for boys to not to pay attention at school. So we see that girls have better study attitudes. Now, why would this be impacted by the school context? Well, because of Robert Merton. We know that people take reference groups to compare their own situation against. Those are comparative reference groups, but also to take over their norms, to see what is successful, what is not. You inspect another one's norms, and then you can eventually choose to adopt those norms. That's normative reference group taking. Now, what is important in reference group taking is visibility. In very simple terms, you will not inspect norms of a group whom you never meet. If I never meet any Americans, for example, why would I ever inspect the norms of an American? You see? So the groups that you encounter are, of course, determined by structural features. In very simple terms, if I'm a boy in a boys' school, why would I ever take the girls as a normative reference group? Because I never meet them. All right? So this is useful for linking structural school characteristics, those gender composition, to the study attitudes. And as we know that when students value studying, they will be less likely to be deviant in a school context. We think that the gender composition affects school misconduct. So this is the idea. We have an input process output model where we have a structural school characteristic impacting on individual attitudes, because normative reference group taking actually doesn't say anything about a culture at the school level. So that's not figured here in my model. And my outcome is school misconduct. So that's the ID. These are my research questions. Is the proportion of girls associated with study attitudes first? Is it associated with school misconduct? And is the effect of gender composition on school misconduct mediated by the study attitudes? So if I look at it here, is there a direct effect of this on this? First research question, direct effect of this on this, and is there an indirect effect of this on this and then on this? That's the idea, all right? I only show you the last one. Oh, the second and the third one, not the first one, because that's another analysis. I will do a multi-level analysis. First thing is it necessary? So first you do your null model. This is what my null model on school misconduct shows. This is the intercept. It's actually just the mean of an intercept, so it's a mean of the outcome. This is my variance within schools, and this is between schools. think I've made a mistake here. It's the other way around. Between is less, of course, than within. So it's the other way around. The proportion of variance at the school level is, and this is correct, is 7%. It's actually a little bit the same as our belonging example that we had previously. Okay, so the U, the error term at the school level, is significant. So the intercept, this one, differs between schools. So to answer the traditional school affective studies answer, the school makes a difference. All right? What is that difference? This is my table of the multi-level analysis. We'll do a mediation. So we'll work stepwise. All right? This is how we assess mediation. We first assess the direct effect, then we put in the supposed mediator, and then if the first effect disappears, then there's no direct effect anymore, and it was an indirect effect. Okay? You're familiar with this Baron-Kenny method? All right. So if you don't know it, Baron and Kenny. These two have done it in 1985, I think. That's the method that I use. So what we find here is, of course, there are a lot of control variables not shown here because they're not important for my main argument, but they are included, like gender, but this is shown, SES is included, ethnicity, grade, etc. So those things are present in the model. That's important to say. First, what we see is that the gender composition has an effect. More girls at school, because this is the proportion of girls, so more girls at school makes for less school misconduct. Right? So this was the hypothesis. Important is, when you investigate composition effects, that you always enter the individual variable as well. This is actually not valid to make conclusions about. If you want to have the gender composition in your model, you need to have gender at the individual level as well. Because otherwise it could be a selection effect. If there are more girls at school, of course, there are more girls at the individual level. See? And if you want to make sure that it's really a composition effect and not simply a selection effect of the individual students present in the school, you always need to control for your individual variable as well. So if you want to do an ethnic composition effect, you need to have ethnicity at the individual level. If you want to have the SES composition, you need to have SES on the individual level. Okay? That's an important thing. All right, but it remains. It gets a bit smaller. There was a selection effect here. It gets a little bit smaller, but it stays significant. All right. Third model was with a couple of control variables added, so there's no difference here, but you see that it doesn't make a difference in my model. When I entered the study, the interaction term was added here. In my third model, the interaction term was added just to see whether the effect of gender composition differs between girls or boys. This is a cross-level interaction term where the effect, the slope of gender, this one, is allowed to vary by the gender composition. But it's not significant. You see? So it's the same for girls and for boys. All right. Here the study involvement was added. It has a large negative effect, which we supposed. If you value studying, then you will be less likely to counter the school rules. So that's actually quite straightforward. But we see that the effect of gender composition disappears. This is the direct effect when we control for our mediator. And it's gone. It's not significantly different from zero. All right? So we see that it's mediated by the study involvement. In the last model, there were some additional control variables added, but the idea roughly stays the same. So indeed, our theory is supported, probably because of normative reference group taking. When there are more girls at school, everybody is more obedient, also the girls. If there are more boys at school, then the boys that are less likely to take girls as normative reference group, so they value studying less, more likely to be deviant, and the girls are also more likely to take boys as normative reference group, and they tend to misbehave. What we're doing now is we're going in our third part of the presentation, and we'll see how we can incorporate teacher data in our models. Let me first say that this is very easy to do, so it's not difficult at all. But multi-level analysis is a very good technique of incorporating teacher-reported data with student-reported data. So linking a data set of answers reported by teachers with a data set answers reported by students. Okay, so multi-level analysis is really a good technique to do so. So let me first start by the teacher. I have a very excellent photograph here to show how important the teacher is, of course. If you have a bad teacher, then you won't understand anything about the course material. If I'm a bad teacher today, you won't have any knowledge about multi-level analysis at all. If you're stuck with the same bad teacher for the entire year, of course you can be lagging seriously behind than your counterparts in the other classroom, maybe in the same school, that have the good teacher. All right, so teachers are very, very important, of course, in education. Why? Because he makes the lessons, he or she makes the lessons, of course. In Flanders, I don't know how it is in Poland, but in Flanders his role is very large. Makes the exams, grades the exams, makes recommendations based on the grading of the exams that he made based on the lessons that he made. So it's the most important person in your entire educational career, the teacher. All right. Of course, you see them a lot. Especially in primary education, one teacher, you spend an entire year with your teacher, maybe even more moments than with your parents. So it's an important figure in your life. Let's just say that. So this has originated, of course, a lot of research on the effects of teachers. I think the most important and the most well-known example of this kind of research is the Pygmalion study by Rosenthal and Jacobson in the 60s in America. Now, what did they do? They performed an experiment in a primary school. So they went to a classroom and they had IQ tests with them. And so they distributed it among the students, and students had to make the IQ tests. While they were doing the tests, they went to the teacher and they said, okay, this is a new test that we developed to make predictions about the future academic progress of each student. And based on this test, we will see which students are the bloomers, which means these will make extraordinary educational growth, and which are not, which are just regular students. Of course, they were lying because it was just an IQ test. Okay? After the tests, they went to the teacher and they said, just randomly selected students, these are the bloomers. But they were randomly selected across all students. They were not the students with the high IQ or something, just randomly selected students. They went with the name of these students to the teacher and said, these are the bloomers in your classroom. 8 months later, they went back. They did the same IQ tests. And what did they see, of course? That the students that were deemed bloomers, but actually were randomly chosen, made the largest academic progress during the years. Very controversial. A storm erupted in science, but also in the media, about teacher effects. And so the idea was that if teachers have expectations that may be wrong, they may be accurate, that they eventually come true. So that's a self-fulfilling prophecy, all right? An attitude that you have becomes reality just because you have that attitude. Now, recent studies have shown that this idea should be corrected a little bit. Most of the expectations of teachers are not stereotypes, are actually quite accurate, because as I've said, teachers of course spend a lot of time with their students, so they know them. Their expectations about educational growth mostly are accurate, but they have effects on cognitive growth. So the students where there are larger expectations for, they actually make more growth, educational growth, they feel better, etc., than the other students. So in other words, teachers tend to magnify existing differences rather than try to help the lagging students, those who are lagging behind, to keep up with the group. That's the idea. Okay. Previous research on this, because of methodological constrictions, of course, they had to investigate this either with teacher data, sorry, I started student data, sorry, either with student data. So what they did is they asked students, how do you think your teachers think about you? Okay, so it's the student perceptions of these teacher expectations, and then their own reports of their outcomes. How do they feel, how do they progress, etc. Student side of the story. Other research has looked at the teacher side of the story, asking teachers, what do you expect of your students, and how do you perceive their outcomes? Of course that this correlates a lot, because it's the same individual, either the student or the teachers, reporting both sides. All right? First, I'll start here. This creates problems of shared method variance. It's just what I said. Just because the same individual is reporting the same measures can create correlations between these measures. Just because it's the same individual filling it in a survey. Okay? So it's better to have teacher reports of their expectations and student reports of their outcomes, of course. Okay. Second problem is that student and teachers' reports differ from one another, which shows that teachers' perceptions about their students are not accurate, and reverse, students' perceptions of their teachers are also not accurate. All right? So this is a flawed way of working. It would be much better, as I explained previously, to have teacher data on their expectations and student data on their outcomes, and then mix it together and put it in the same analyses. Of course, that's difficult to do, because you have two samples. You have a sample of teachers, you have a sample of students, and it's very difficult to link these two samples in one analysis. You can't just put them together in SPSS and run it. It doesn't work that way. It doesn't work. But multi-level analysis gives us a very straightforward and easy solution to do so. Because if we see that teachers' expectations, or in general, if we want to go away from this Pygmalion framework, just their attitudes in general, if they are shared by the teachers of the same school, then we can aggregate that to the school level, because then it's a teacher culture. And a teacher culture is not a characteristic of teachers within the same school. No, it's a characteristic of the school. And then you can put it in at the higher level. You see? So, if you want to do this kind of research, you first have to see, with the index of mean rate reliability, etc., whether the attitudes of the teachers are shared within the same school. If it's a culture, then you can think that the culture eventually socializes individual teachers' attitudes, and it's actually a correct manifestation of the individual teacher attitudes. All right? So this is how we will do it. And I have an example from my own research. I think this is a very good picture. So what I did in my PhD project is looking at whether teacher expectations, because I was interested in school misconduct, of course, affects school misconduct by students. If students are confronted with teachers that actually have low expectations of them, maybe they can eventually say, I won't follow your rules anymore, I'll disrupt your lessons, and they will become deviant. That's the idea of this study. So first he shouts, and then he shouts back. That's the idea, all right? So the Pygmalion effect is, of course, my theoretical framework here. I've explained it thoroughly, I think, now. What I didn't explain is how these expectations eventually affect student outcomes. There is a mediator between teacher expectations and student outcomes, and that is differential treatment. What we see is that teachers treat students differently based on the expectations that they hold for them. And that falls apart in two concepts: effort and effect. We see that teachers put less effort in students where they hold lower expectations for. So if I, for example, have a student in my class and I think he will never understand what I'm saying, then I will put less effort into trying to make sure that he follows me. All right. There's also a thing called affect. I will develop, as a teacher, I will develop less effective relationship with the students for whom I hold lower expectations. So there are less supportive teacher-student relationships. Okay, very briefly. So how can we relate this to school misconduct? Well, using two criminological theories. First, strain theory. Strain theory very briefly says that if I want to attain a goal and someone is blocking me from attaining that goal, then I will react against that goal blockage. I will be frustrated and I will give up my goal altogether. That's the idea of strain theory. So, converse to this context here. If I want to attain good grades, but I'm in a classroom where my teacher doesn't put a lot of effort in teaching me, then my goal is blocked. So I will eventually react against the teacher by opposing his rules or her rules. That's strain theory. We also have social control theory, of course, by Travis Hirschi, which says that if I have strong bonds, effective bonds with someone else, that I will not cross his or her rules. If I have less effective relationships with my teacher, why would I bother to follow his rules or her rules? So lower effort and lower effect may eventually lead to school misconduct. So what we did is, first we looked whether expectations are shared by the teachers of the same school. It was, so we could make a teacher culture of expectations. It's important to note that this is reported by the teachers, aggregated to the school level. This is reported by the students, the sense of utility, actually a measure of goal blockage. All right? And this is, again, reported by the students, their bond to their teachers. Do you perceive to have supportive relationships with your teachers? And this is school misconduct. First step, does school misconduct vary across schools? Because if it doesn't, then of course there will be no effect of teacher culture. Always take that first step. But we've already done it, and I made the same mistake here, and because I copy-pasted, and it's 7% again. So it's the same as in the previous example. Okay, then our teacher expectation, okay, I'll show it to you, whether it is actually shared by the teachers of the same school. So our teacher expectations indeed shared among the teachers of the same school. I've already told you the answer, yes they are, but this is how you do it. So you just do an ANOVA with your teacher data. I had 2,076 teachers, I guess, in my sample, something of that. And I did an ANOVA on their expectations. This is the result of that ANOVA. Okay, so just an ANOVA table from SPSS. This is what is interesting to make my index of mean narrator reliability. This is my between mean square. This is my within between square. Of course, we use it to see if there are significant differences between schools, because my groups are the schools here. Okay, so my factor is actually the school ID of the teachers. And my dependent, of course, is the expectations. It differs across schools, but I have to see whether this mean rate reliability index is larger than 0.60. So between minus within, divided again by the between, gives us 0.92, quite large, and larger than 0.60. So then we can just aggregate it by taking the mean in each school. All right? So this is how we do that, with compare means in SPSS. Then put it in Excel, and then put it in your school level SPSS data set. That's the general ID. So these are my tables for this study. First, I looked at whether the teacher culture has an effect, and it has an effect. This is the standardized effect. It's actually rather large, medium to large. And we see that a higher teacher culture of teachability, of expectations, leads to lower school misconduct. What was hypothesized. This is with the control variables entered, and it stays. This is with the sense of utility entered, or measure for goal blockage, remember, from the students. And the effect becomes a little bit smaller, but it stays significant. All right, so it's not this goal blockage that explains away my effect at the school level. But the perceived teacher support, which is my measure for affect, remember, based on social control theory, eventually erases my effect here. See? So it's mediated by the perceived teacher support here. Okay. Let me use this table to make a point again. I had 84 schools in this sample. This is significant at the 10% significance level. Why? Because this significance testing is made based on the n of the number of schools, so 85. This is based on my number of students, which was almost 12,000 here. So here I must be much stricter to allow significance than here. At a higher level, you can be satisfied with a significance level of 10%. Because, as I've explained, because your n is that small, it's much harder to gain significance here. Say you have a sample of about 30 schools, then you may be even less strict here. Because with a sample of 30 schools, to be significant on the 10% level is already a lot. Okay, so that's something important to know from multi-level analysis. Okay, so with colors, these were my hypotheses. So of course, goal blockage leads to school misconduct. That is what strain theory says. This is social control theory. But the effect of the teacher culture of expectations, again reported by the teachers, eventually vanishes if I take this into account, these bond to the teachers. Okay, this was the part about teachers. So now I'm ending my, starting my final part, but it's quite small. You can make several extensions to this basic multi-level model. Now it's been a two-level model all the way, schools and students, etc. You can extend that with quite different things, even more things than I will talk about here. You can have, for example, cross-classified models. What are cross-classified models? Is where the same individual can be nested in one higher level unit, but also in another one. For example, a student goes to school, but also live in a certain community. That's cross-classified, all right? That's not nested, because not every student in the same school is in the same country, etc. That's nested data. Cross-classified is that you belong to other contexts that are next to each other. I will not go into much detail about that, but there are techniques to allow for that. This is nested, so I will stay within the nested thing. You can extend it upwards. For example, take into account the city level, educational system level, the country level, etc. So you can use this for cross-national research, for example. You can also put intermediate levels, where this is the school, and this is the classroom, and this is the student. Or this is the school, this is the grade, this is the classroom, and this is the student, for example. Tracks. That's also a relatively new brand of research where you have schools. In Flemish research, that's possible, for example. You have the school, you have the track where a student is entered, general track, vocational track, etc. And then here you have the student. You can also extend it downwards. Multi-level analysis is very well suited to do longitudinal research, where you have the school, for example, the student, and then measurement at time 1 for this student on a certain scale, measurement time 2, measurement time 3, etc. So then your time, your measurement waves are your lower level. Say you would do a longitudinal cross-national research, if you would be so crazy to do so, for example, then you need a 4-level model, where you have your longitudinal here, student, school, and national level. So you need a 4-level model to do so. There are other extensions possible, as I've said, but these are the things that popped in my mind when I was thinking about that. I'll say a little bit more about cross-national studies, but very briefly. Again, data. We can have data on the national level. But it's important to know then that this data cannot differ between schools or between students. For example, the GDP, the Gini coefficient of a country, is the same for every student within that country, is the same for every school within that country. The system that is used in secondary education, is it a tracked one, is it a unified one, is it a linked one? The school selectivity. Are schools allowed to select their students or not? That's a national policy choice affecting schools and students. Freedom of school choice, same, use of standardized test scores. So those are choices made at the educational system level. Of course, there's a lot of research already existing in this domain, mostly using large-scale international surveys. We all know PISA, I think, but also TIMSS, PEARLS, etc. are those large standardized surveys used in a lot of countries, etc. But we can actually make the same critiques about this kind of research than the traditional school effect studies. What they mostly do is they just relate system-level properties to student outcomes. 2-level model. And they don't look, actually, again, the input-output model, and they seldom look at processes. For example, belonging. How do belonging mediate the effect of a system-level property, for example, whether systems are tracked or not, on ability on math scores, for example? Seldom done. So, doing so would give us an explanation for system-level differences, of course. Just the same critique as I had on school effectiveness studies, school effect studies can be said about these large-scale PISA studies. They seldom have longitudinal data because it's so difficult to do so, because you need a lot of levels, etc. And the school effect studies, which are around since the 60s, are mostly totally neglected in this kind of research. As I said, 2-level models, you have the country and the students. But we know that students, of course, are nested within schools. And as I've said, even within those countries here, you can have problems of autocorrelation. So you need to have a school level as an intermediate level here. Just to give you an idea how system and school level effects may interact and work within each other. This is the effect of SES composition. It's not a study of mine, by the way. It's a PhD of Alison Dunn at the University of Florence in Italy. So just to be sure, she's also in the further reading session. So if you want to have more information on that, you can find that there. So this is the effect of the SES composition on the score of PISA tests. And these are systems that are comprehensive, so no track. This is internally differentiated educational systems. They are tracked, but not so much, you can say. And these are highly differentiated education systems. And what you see is that there is a cross-level interaction cross-level interaction effect between system-level makeup and the effect of SES composition. If you have comprehensive systems, then there's a lot of variability between schools in intercepts, but the effect of SES composition is much smaller on score than in the highly differentiated educational systems. Here, there's a very low level of variance. Every school actually performs or has the same effect, that's what I want to say, but the effect is much steeper. So if you have a tracked system, then the SES composition is much more important to determine your score. So it's important to incorporate school effects in cross-national studies. That's the point that I want to make. They can mediate, they can moderate system-level effects, so it's important to include them. Because of course this is what happens if you neglect them. You have biased estimates. If you don't account for this SES composition, for example, you will never see that it has different effects in different systems. You will just take a mean effect, which is of course biased. Results might only apply in specific settings. If you don't take into account some contextual features, they will never find differences between specific settings, and you, roughly stated, make wrong conclusions because of the problem of autocorrelation. The problem is that you need enough units at the highest level. Because as I've said, significance testing at the highest level only uses the number of units at the highest level. If you have cross-national research where you only investigate 3 countries, then your N at the highest level is 3. And your significance testing will only use 3 units. Okay? So this is a very important pitfall in cross-national research. Some say that you need at least 25 units at the highest level to be able to make some predictions. Again, a lot of discussions about that. Personally, I think that if you are aware of this problem and you know that you don't have to that you can't put a lot of variables at the highest level, and you are a little bit tolerant about the significance level at your higher level, then you can account for this. Okay? But it's not possible to do a multi-level analysis at the highest level only 2 countries. It's not possible. You need at least 12, for example. Just a random number. And this is the nirvana. This is where we want to come, where you have structural things at the national level, at the educational system level, and where you can explain these things by structural school effects, but also, of course, by processes, school culture. School social system is not here, attitudes, behavior, relationships, and maybe even a culture at your national level. But I don't know if it's possible. But it is the nirvana, so the nirvana should not be possible. This is what we want to attain. Okay, so I reached the conclusion of this lecture. Multi-level analysis, important. In educational research, in my view, if you don't do multi-level analysis in educational research, you are at a very high risk of making wrong conclusions because of the large problem of autocorrelation in your data. Students are nested within schools. Even if you don't want to investigate school effects, you need at least to partition your variance among the school level and the individual level. Okay, so I think this is, especially for educational scientists, also for other social scientists, of course, important to take away. So also statistically, of course, but also theoretically. Many of the theories that we have, especially structuralist theories, look at the effect of contextual characteristics on outcomes, so you need multi-level analysis to do that. I'm a big fan of input, process, output models, if that was not clear by now. So you have to open black boxes and be theoretically founded. Use sociological theories, middle range theories to guide your hypotheses. And not just put everything in your data and see what comes out, because they may be statistical artifacts. It's a good technique to incorporate teacher-reported data and avoid the pitfalls of shared method variance, etc., what I've talked about. And it's also important for cross-national research, but look at the number of units at the highest level. If you want to read, there's a lot to do. I will not go over everything, just see what you can do. There's some things about statistics of multi-level analysis. I especially recommend the highest one there, Hox. It's a very approachable book for multi-level analysis. The discussion of school climate, this is what I'm based on, but you can differ in opinion from me. This is how we conceptualize school culture with the mean rate, reliability, etc. This is a text about incorporating teacher effects. This is the thing about looking at school effect and national effects at the same time. Also very new research, so a lot to do in this domain here. And these are my own articles from which I've drawn my examples today. So all I can say now is thanks for your attention. For the people at home, thanks for watching this video. So, thank you.